Welcome back to The Explainer. Today we're diving into something truly wild. We are building a bottom-up map of how deterministic math actually anchors high-dimensional governance straight into our physical reality. Seriously, if you've ever wondered how abstract digital rules manage to flawlessly control the physical world without, completely crashing, well, you are in the exact right place.
All right, so here's our roadmap for today. First, the dimensional translation problem. 2, 64-bit deterministic portals. Number 3, enforcing Pell-Smith logic. 4, building 3D voxel substrates. And we'll wrap up with 5, the 4D governance window. Let's get right into it.
Starting off with Section 1, the dimensional translation problem, or human imagination versus silicon.
So, here's the fundamental bottleneck. How on earth do we govern four-dimensional rules in a 3D world? We face this massive translation problem when we try to manage high-dimensional temporal rules, things that change over time using flat, rigid, physical hardware. It is a real clash of worlds.
And there is a huge divide here. On one side, we have our messy human intent, what's called OS alpha. Our minds are basically like a flowing river. They're fluid, boundless, highly associative, and probabilistic. But on the exact opposite end, we have the arithmetic logic unit, or the ALU, inside a computer chip. That hardware is cold, it's blind, it operates strictly on exact voltages, and it is 100% deterministic.
So when we try to force that beautifully fluid river of human thought through traditional computer processors, we slam right into what's known as the observer paradox. Standard systems rely on a floating point unit, or the FPU, and because the sheer complexity of what it's trying to observe totally exceeds the hardware's physical limits, the FPU basically just becomes a lossy statistical guesser. It approximates the math, and over time, that creates a catastrophic amount of informational debt and data drift.
Which brings us to Section 2. 64-bit deterministic portals are absolute foundation.
To fix this massive drift problem, we have the Portal project. And this is absolutely crucial. It completely replaces that unpredictable stochastic execution with a totally absolute, audit-ready deterministic pipeline. We're taking high-dimensional Pell-Smith logic and tetrad math and mapping them directly into a rigid 64-bit deterministic substrate. There is literally no guessing allowed here.
Pulling this off requires some intense rigor. Opening a perfectly stable deterministic portal is a strict sequential process. It starts all the way down at quantum state initialization, moves through stabilization phases, right up to controlled expansion. We are basically taking pure fluid dynamics and mapping them into highly structured topological engineering. Every single data point gets an exact permanent home.
Now, to keep things stable, the system uses a LIFO state tree. That stands for last in, first out. Think of this thing as a totally ruthless logical bouncer at the door of your database. It only checks index 0, the guy right at the front of the line, to get the absolute mathematical state of the system. If it finds any conflicting data, it violently rejects the input. So what we get is flawless single-entry bookkeeping that maintains a bit-perfect, completely non-halting history.
Moving right along to Section 3, enforcing Pell-Smith logic, or the causal verification engine.
This quote right here really nails the ultimate paradigm shift. By using the Pell-Smith stride, we move from approximating a curve to possessing the state of the manifold. Think about that for a second. We aren't just approximating reality anymore. We are mathematically possessing its exact indisputable state. And the efficiency of doing this, it is completely off the charts. By anchoring to a discrete rational lattice, rather than doing all that complex trigonometric scoring, the metabolic energy needed drops down to a staggering 0.05 picojoules per operation. That is a truly massive deflation in the energy required to process data.
We actually achieve this mind-blowing efficiency by liquidating our observer debt. We just completely walk away from the sloppy guessing games of the FPU, and we relocate the math safely straight into the exact arithmetic logic unit. Because in the ALU, 1 plus 1 is exactly 2, every single time. Okay, Section 4, building 3D voxel substrates. Let's look at the actual physics of it all.
So, we've got perfect math and perfect logic. But how does this abstract stuff physically manifest so we can use it? Well, we use what's called a macro to micro funnel. It's like we squeeze our abstract human intent, that spark in OS alpha, through a rigid textual bridge. raw intent becomes structured text, which is serialized into precise spatial vectors, then rendered into actual geometric 3D voxel blocks before finally being executed deterministically by the hardware. This whole process creates what's called a volumetric proof of sweat. We are way past just recording flat entries in a spreadsheet. With these 3D voxel engines, computer programming literally becomes masonry. You are building spatial vectors where logic gates act like physical brick walls you can actually walk around in a digital space. It's wild.
And finally, Section 5, the 4D governance window. Let's look at the macro application of this entire stack.
Let's pull all these pieces together. We take that solid 3D voxel substrate and we apply higher dimensional coordination rules to propel it through time. This is where 4D management comes in, handling insanely complex logistics and schedules using 4D building information modeling. It evaluates everything across 4 key metrics: depth, which is collaboration; dimension, meaning scale; dazzling, representing density; and delight, which tracks the overall health of the network. It seamlessly tracks physical assets across time and space.
A brilliant real-world example of this 4D window in action is the Alaska Ocean Observing System. It takes vast, incredibly diverse environmental data sets and standardizes them onto a spatial grid over physical geography. It basically unifies massive amounts of temporal data so researchers can literally see and track dynamic changes over time, all in one place.
Ultimately, this architecture acts as the chopsticks of reality. We don't need to somehow exist in the 4th dimension to manage it. Instead, this deterministic portal acts as the ultimate webhook. It safely anchors those high-dimensional spatiotemporal rules straight into our physical 3D hardware without breaking a thing.
It's an incredibly powerful system, but it relies entirely on us authoring that exact textual bridge. So I want to leave you with a provocative thought today. As we increasingly rely on probabilistic AI models, if we stop writing that deterministic bridge ourselves and we just surrender it to automation, who actually controls the physics of our digital reality? Keep that in mind the next time you let a machine guess your intent. Thanks so much for joining me on this explainer, and keep looking past the screen.